Bless you. Notes. 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 Okay, we're loaded. Now we're good to go. Last thing. The set of all possible outcomes in a probability experiment is called the sample space of an experiment. Your sample space is all the possible outcomes in a probability experiment. We're going to look at one specific way to look at sample spaces, but there's actually 3 ways you could see things. Sample space can be used, or these 3 things can be used to look at sample space. You could make a list of your possibilities. You can make a table, or you can make something called a tree diagram. Isaiah on task. Tree diagrams are what we're focusing on today. Reviewing yesterday's work, we looked at simple probability problems, and what you did is you had to divide the top number, which was all the favorable outcomes. So for number 3, we looked at the dice of like not rolling a 1 or a 3. Your favorable outcomes would be anything that's not a 3. Then you divide that by your total outcomes, and you get some percentage or some fraction or some decimal. Okay, so we're still going to use what we did yesterday. We're still dividing that, but we're adding something a little bit different. Brayden, you go to the pizza store, you're ordering a pizza. Read example 1 for us. Okay, so we are going to set up a tree diagram like this. Notice how this isn't just like one dice that you're looking at. There's a whole bunch of things that's going on with this. When you go to the pizza store, you can have either stuffed crust or thin crust. Write S or T on your paper. This stands for stuffed, T is thin. When you order stuffed crust, you can have either Hawaiian, you can have sausage, you can have pepperoni, or you can have an olive pizza. Gross. So your options are a stuffed crust with Hawaiian, stuffed with sausage. Let's make SA so we're not confusing the two. You can have stuffed with pepperoni or stuffed with olives. But there's another option for you, Brayden. You could get thin crust. Gross. You could have thin with Hawaiian. You could have thin with sausage. You could have thin with pepperoni. You could have thin with olives. How many types of pizza could you have, Carson? 1, 2, 3, 4, 5, 6, 7, 8. There are 8 types. So you just made a sample space with all of your combinations using this thing called a tree diagram. Yeah, Grant. Okay, if you catch your train of thoughts, I hope it comes back to you. It's lost somewhere in the brain of Grant, and we hope you find it. When we're done with this, we might create wanted posters for your thought. So here's what we're actually doing today, though. Taylor, track the board. We want to know the probability. Underline probability. What's the probability that you're going to order stuffed crust with pepperoni? Go up to your sample space. Your tree diagram's your friend now because you know all the different types you can order. If you want stuffed crust with pepperoni, circle, stuffed crust with pepperoni. That is one type of pizza you could order. Out of how many options? Grant.
I don't have the answer, but I found my train of thought.
Okay, I'm going to pause you because we're going to finish our train of thought so I don't lose mine. Write down your train of thought so you don't lose it again. Carson, how many options?
8.
8. So the probability P of stuffed crust with pepperoni is going to be one option, Taylor, board to paper. You have one option. How many circles did I circle, or how many options did I circle? One option out of the 8. So 1/8 is our probability. Grant.
And I'm pretty sure there should be more than 8 combinations of pizza.
Oh, why?
Because there's stuffed crust, there's thin. So that would be 10. What? What?
Oh,
Stuffed crust.
so I see what you're saying. Let's explore that because I want to clear things up. Stuffed crust and thin over here, like when you go to the pizza place, maybe this is your go-to, but you usually don't say, hey, can I get a stuffed crust pizza with what on it? Nothing. I just want stuffed. Well, with like what on it? Just stuffed. No one does that because you always have one topping at least, like cheese or something on that. Voice.
Cheese isn't on there.
We're going to assume there's cheese. So here's what the tree diagram does, you guys. Voice. 3, 2, 1. What you just found was really stuffed crust with Hawaiian, then stuffed crust with sausage, then stuffed crust with pepperoni, then stuffed crust with olives. Do you see, Grant, how stuffed crust is already included in all these options? So you're not just ordering some sausage like on the side without a pizza. You're actually ordering the stuffed crust with pepperoni. Does that make sense?
But there's still different combinations.
This is all you can have because this is stuffed crust with Hawaiian, stuffed with sausage, stuffed with pepperoni, stuffed with olives. You can't order just a stuffed crust pizza.
I know, but like if you do like sausage and pepperoni, and then you do olives and pepperoni.
We're just getting, I see. We're just getting one topping. So we're saying this is a one topping deal only. You can only get one topping.
Okay.
1/8 is going to be what decimal? Plug it into your calculator. Go. Shiloh, calculator up. 1 divided by 8. What is it? I want to hand Isaiah.
0.125.
Okay. What percent is that, Evelyn? What percent is that, Evelyn? Okay. Okay, that's probability. Next page, please. Clayton.
I have a question.
Yeah.
So, do we not round up the percentages, like, or the decimal?
You can if you want to make it 0.13. I'll accept either one as 100%. Okay? Next page. That's cool. I think most of us don't yet. This is a pretty new concept. So check your voice. 3, 2, 1. Brea Bryden, that's your first. Brea Bryden. Okay. Number 2. Read it for us, please, Maya. Okay, so we're starting off with bread. We're going to either have rye, sourdough, or white. Those are the 3 options of bread. Up here is your bread options. With your toppings or your fillings of the sandwich, you can either have ham or turkey. So rye can either have rye with ham or rye with turkey. You can get a rye ham sandwich or a rye turkey sandwich. Thumb up when you have that on your paper. Rye ham or rye turkey. Okay, let's move on to the sourdough. You can get either ham or turkey on a sourdough. So you could have sourdough ham or sourdough turkey sandwich. There's another option. You could have white bread, ham or turkey. So you could get white with ham, white with turkey. Those are your options. How many options are there, Blake? 1, 2, 3, 4, 5, 6. There's 6. So what's the probability of choosing a turkey sandwich or sourdough? Or sorry, what's the probability of choosing turkey dough, my goodness, I can't talk. Turkey dough sandwich. Turkey sandwich on sourdough bread. Probability of turkey with sourdough. Leighton.
Kind of this, but kind of not.
Do you have the answer for this? I'm gonna pause your thought. I'm gonna
I
pause your thought because I'm gonna get the answer first.
think I know.
Okay, what's the answer?
I think it's 1/3, correct?
Okay, we have one turkey sourdough sandwich out of how many options? 1, 2, 3, 4, 5, 6.
Oh, including him.
All of these are different sandwiches. These doubled up are different sandwiches, so you have 1/6 as an option. 1 divided by 6, was that what we just did before?
No.
What's 1 divided by 6? Kevin. Okay, so we'll round to 0.17. What percentage is that, Miles? Yeah. Okay, there's all your possibilities. Another one. Suppose you toss a quarter, a dime, and a nickel. We want to find the sample space for all the possible ways it can land heads or tails. This one's a little trickier, so track the board and notice the difference. We have a nickel that we're going to flip, and it's going to be either heads or tails. That's flip number 1. Write that. Board of paper, Taylor. Put it down. Right, and erase it and put what we have. It's not quite right. You can have another flip, and this time, this looks a little different. Your second flip, if you got heads, it could be heads or tails. If you got tails the first time, it could be heads or tails from that one. Okay. Your third flip, could be, if you got heads and heads, it would be heads or tails from that one. If you got heads then tails, it would be heads then tails. If you got tails then heads, it would be heads or tails. Tails and tails, it would be heads or tails. Okay, this one looks slightly different because with a coin, you're not having like a different type of sandwich, you're just having a different scenario. So if you don't have space right below here, make a line and go underneath this problem. And we're gonna look at all the scenarios. So you can have heads, heads, or heads. If you got heads 3 times, that's one option. Heads, heads, and heads. H, H, H. Okay. If you got heads the first time, heads the second time, and tails the third time, you would have heads, heads, tails. Isaiah, if you got heads, then tails, what's the next option? Heads, tails, with heads. Okay, head, tail, head is the third option. Notice how I'm going down the line. So I've done this. I'm going to go to heads, tails, tails. Heads, tails, then tails. Okay, that is done. What if you get tails the first time? Well, you could have tails, then heads, then heads. That's also an option. Josh, board to paper. You could have tails, heads, then tails. Okay, I've done that. What's another option that I could have? Bryden. What's my next option?
Tails, tails, and heads.
Yeah. You could have tails, tails, heads, and what's the final option? Write it down if you have it. I'll check it in 30 seconds. Huh? She is not. She did not come to class today. Yep. Okay, these are all of our options. Scale 1 to 5. Where are you at with this process? Probably a 1, I'm guessing maybe a 0. Show me. Hands down, this tends to be the hardest of your probability tree diagrams. So we'll do one more of these, but let's look for the probability of getting 3 tails. So if I'm looking for 3 tails, how many times do you have all tails as an option? Get ready to turn and talk in 10 seconds. How many times do you get all tails in this option? Turn and talk, 10 seconds, go. 3, 2, 1. Okay, track the board. We're going to put the probability of all tails, and that's going to be how many times, Isaiah?
24.
So
Wait, 1 of 24.
1 out of, there's 1 all tails. How many options are there? This was your first roll. This is your second option. This is your third. This is your fourth. This is your fifth. So notice how the options include the 3 rolls. You can't just roll it 1 time because it says you rolled it 3 times. It's 1 out of Leighton. How many times? Yeah, 1/8. Divide 1 by 8. One divided by 8 is what, Evelyn? 1 what? Okay. And that could round up to 0.13 or 13%. What's the probability of getting 2 heads and 1 tail? Second problem. We did A, let's do B. 2 heads and 1 tail. This time it doesn't matter what the order is. How many times did we get 2 heads and a tail? Let's circle this one. The second roll, you got 2 heads and a tail. Do you see another time that you got 2 heads and 1 tail? Turn and talk to your partner, search for 2 heads and a tail, circle it. If you see it, go. It doesn't matter the order. I see 2 heads and 1 tail right there. I see 2 heads and 1 tail right here. I see 2 tails and a head. That didn't work. 2 tails and a head, 3 tails. So I only have... How many times did I get 2 heads and a tail, Shiloh? 3 times. So this is 3 out of 8. 3 divided by 8 is what, Josh? Okay. That could round to 0.38. And that could be Miles, what percentage? Okay. That is your total. Last one. Number 4, Kevin, read our final example. Turn and talk to your partner. What letters go on the top of my tree diagram? Go. 3, 2, 1. Grant, what are you and Josh thinking? What letters go on the top? Yeah, the male and female are the 2 types, M and F. Out of those male and female, there are how many types that we could have, Isaiah? How many types? There's yellow, black, or brown. Maya, where do I put yellow, black, and brown? Yeah, there could be a male yellow, a male black, BL, and a male brown. There could be a female yellow, a female black, or a female brown. So let's write the options. Male yellow, male black, male brown. Don't go into data and statistics in your future, Grant. Then go into female yellow, then female black. Did you say you don't like this? Yeah. I thought or was that you, Josh? Yeah, a lot of people, you guys, I've warned you, I think yesterday and then maybe the day before, the data and statistics is like a whole other branch of math that people either hate or they love it. It's either a hate relationship because it's really boring and monotonous. If you love it, it's because it's kind of simple for you. Boys, 3, 2, 1. Okay, Carson, what's the probability of choosing a yellow female? Let's write probability of FY. We want a female that's yellow. What's that probability, Carson?
It's 164.17.
Good. Okay. Question, Carson. If you guys go into some data and statistics field at college, a lot of the sciencey kind of like experimental type of problems, like snowpack for the fire department, they have a lot of statisticians who go out into the different forests and kind of look for the probability of wildfires going into that area. So they use a whole bunch of variables. They get like tree diagrams that are in computers and they plug in different things like the wind, the temperature in July, past fires, how much vegetation, and they plug it into computers. You guys won't ever be drawing tree diagrams in your job because that's pretty simple, but you will be using the behind the scenes work that computers do, and that's how you might use it in your job. There's a bunch of fields that use it too, but not just. I know for the fire department, I saw actually a job online that was paying how much a week? It was more than I make. I think it was like $1,500 a week, which was like $6,000. Taylor.
Yeah. For those who don't want to do that, why do you?
Because you need to pass 7th grade so you can graduate 8th grade.
That's
Right.
no.
And I like this, but why would anyone want to do that job?
So some people like to be in nature. I think the fire department job would be cool because you get to go into the forest. I love hiking, and you can like go like just all over the world or all over the country.
Except it's not green; it looks red.
Which one?
The fire department. If you're in a forest fire.
Oh yeah. Well, this person would.
It's gonna turn red.
Black. Yeah. Boys, 3, 2, 1. Okay, you have 4 problems. I'm going to 5, 10. I'm gonna put 7 minutes on the board. You're gonna rank yourself, or you guys just ranked yourself. If you were like about a 1 or a 2 when you ranked yourself on the tails problem, you're gonna look at the board and work with me. If you are a 3, 4, or 5, you're gonna go solo and go as fast as you can through these, getting them correct, checking answers. If you're done, grab a homework page to the right, and we'll start test corrections in 7 minutes. Yeah. Sign up. Yeah. I mentioned that at the start. It's on the board. At the start of the class. Yeah. There you go.
Tessa Myers, come to the office. Tessa Myers to the office.